In the shadow of Geneva, beneath the Earth's floor, lies a marvel of human ingenuity and a capacity harbinger of obliteration. The Monster Hadron Collider. It's far a manual of shrewd assessment, allowing researchers to research the subatomic ordinary and inciting the revelation of the mysterious God particle. At this factor, renowned physicist Brian Cox has recently made a chilling announcement that dispatched shockwaves all through the theological neighborhood. Something big has been investigated at CERN, something that could have profound implications beyond our understanding. Our primary objective for enlightening informational collection places us on a collision direction with calamity. Be a part of us as we dive into this lucid conundrum. Earlier than we delve into the statement, let's explore what a considerable particle accelerator, just like the Massive Hadron Collider LHC, is. Operated through CERN, it is a 17-mile ring of superconducting magnets and the world's maximum effective particle smasher. It represents the top of human clinical success. The LHC can recreate the conditions of the universe's creation. However, must this structure aim to unlock the universe's innermost secrets, it have to additionally be privy to something even greater full size. CERN, established in 1954, is one of the world's most prestigious research institutions with 23 member states and a massive array of experts. It's far a hub for collaboration and innovation. The LHC is CERN's flagship assignment, but simply one a part of an intensive community of accelerators and detectors. This track is for subatomic debris, racing toward the very essence of existence itself. The LHC hurries up protons to almost the speed of light, developing situations that mimic the universe in the meanwhile of the massive bang. The collisions generate temperatures hundreds of thousands of times hotter than the center of the sun. An array of magnets publications the protons on their adventure, whilst intricate cooling systems maintain the magnets chillier than space itself. These encompass 1,232 dipole magnets that bend the beams and 392 quadrupole magnets that cognizance the beams just before collision. Every other form of magnet squeezes the debris closer collectively to boom the probabilities of collisions. The undertaking at CERN is to collide debris with such precision that they meet like two needles hitting each other at 6 miles aside. The precision required is amazing, the development unequaled. The LHC's layout is a wonder of engineering. It includes adjacent beams that lie hidden 574 foot underground, protected from radiation. The whole ring is cooled to -456 degrees Fahrenheit, less warm than the vacuum of space itself. This cold environment is critical for the superconducting magnets to perform optimally. The collision factors inside the LHC are designed to crash at 4 places across the accelerator ring, corresponding to 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each serves a completely unique cause in reading different components of particle physics. Collectively, they act like giant cameras shooting snapshots of those collisions. Researchers then sift through the particles, searching for signs of the elusive Higgs boson, additionally called the God particle, an vital aspect in understanding the universe's essential structure. It's like piecing collectively a cosmic jigsaw puzzle, in which the parts are unknown, and the picture is difficult to comprehend. With the aid of focusing on the microcosm, we gain insights into the universe. But with each answer comes every other query, and with each discovery, any other challenge. The LHC isn't always merely a scientific instrument. It is an image of human innovation and development. It embodies our collective quest for information and our choice to apprehend the fundamental forces that shape our universe. Yet, as we push the boundaries of what we recognize, we need to also don't forget the ethical and existential questions that rise up. What are the risks of exploring the unknown? May want to our quest for mastery inadvertently unleash forces beyond our manipulate? Interior CERN's hallowed halls, in which the frontiers of human knowledge are constantly driven, a discovery has emerged that sends a shiver down even the maximum seasoned scientist's spines. Brian Cox, a former CERN physicist and a leading professional in particle physics, has currently made an announcement that has left the medical community both captivated and alarmed. Cox's phrases resonate with a chilling opportunity. The aim of CERN's Large Hadron Collider is to recreate a mini-massive bang. Certainly, you heard that right, a smaller-scale model of the event that brought our universe into lifestyles. The physicist also highlighted the potential outcomes of this goal, suggesting the LHC's exceptional potential to create new phenomena. This includes its potential to liberate the secrets of the Higgs boson and the observe of dark depend, which constitutes a tremendous part of the universe. Imagine being able to glimpse the actual nature of the universe. That is a tempting opportunity, however, one fraught with hazard. The mini-huge bang is not a trifling theoretical idea. It's miles an impressive truth within the LHC. The temperatures, pressures, and uncooked electricity all replicate the situations of the universe's birth. It's like witnessing the sunrise of life itself. But with such strength comes gigantic duty and the looming question of inherent danger. Remember a situation in which something is going extraordinarily incorrect. Something comparable came about in 1978 while Russian physicist Anatoly Bugorsky suffered a twist of fate that might generally be fatal. While operating at the U-70 synchrotron at the Institute for High-Strength Physics in Prodvino, Russia, a malfunction precipitated his head to be exposed to a proton beam. The beam, with energy that defies comprehension, surpassed through his cranium, entering the back of his head and exiting through his nostril. Bugorsky's enjoy become exceptional. He saw a flash brighter than 1,000 suns, yet he felt no pain. The beam's path left a trail of destruction, burning tissue and bone, but he remained conscious or even walked to the health facility for treatment. The final results was both scary and charming. The beam's direction brought about localized tissue demise, resulting within the loss of hearing in a single ear and partial facial paralysis. However, Bugorsky's cognitive capabilities remained intact, and he persisted his medical work. This occasion isn't merely a private tragedy but a cautionary tale highlighting the big electricity and capacity threat of particle accelerators. The dangers of a particle accelerator like the LHC aren't to be taken gently. The capacity for unexpected reactions, the very fabric of fact being manipulated, aren't the stuff of science fiction, however, actual issues voiced with the aid of a few within the educational network. The universe's secrets aren't simply toys but fundamental forces of nature. One of the maximum alarming issues related to the LHC's experiments is the possibility of creating miniature black holes. Black holes are regions of spacetime wherein gravity is so severe that not even mild can get away. These cosmic vacuum cleaners eat stars and lurk within the shadows of our universe. The concept that the LHC ought to create such entities, even on a tiny scale, is alarming for each scientist and the majority. Ought to this black hollow grow uncontrollably, it is able to devour the Earth from inside. However, CERN scientists have assured us that any black hole created might evaporate almost immediately. No matter these assurances, the far-flung opportunity has sparked debates, fears, and experience of awe at the strength we wield. Understanding how the LHC ought to doubtlessly create a black hollow includes the essential mechanics of particle accelerators. When protons are smashed together at almost the velocity of mild, the electricity is so massive that it warps the material of spacetime itself. Consider a trampoline stretched tight, then a heavy weight dropped onto it. The floor warps and bends, and if the burden is enough, it could create a depression so deep that whatever close by could be drawn into it. That is a crude analogy for what might arise within the LHC. In the realm of quantum physics, where the rules of the universe are each weird and profound, there exists a theory that extra dimensions is probably hidden inside our reality. If those dimensions exist, the LHC's collisions ought to take advantage of them, developing a gravitational property that paperwork a tiny black hole. This unsettling dance of technological know-how and worry has even captured the eye of renowned physicists, along with the late Stephen Hawking. In his e-book, he warned of a scenario where the Higgs boson might emerge as unstable at very high power tiers. This instability could theoretically motive a catastrophic vacuum decay, a cosmic occasion that could no longer simplest destroy Earth, however the whole universe. The esteemed British cosmologist and astrophysicist Sir Martin Rees shared his worries approximately the experiments conducted at CERN in his book on future prospects for humanity. He analyzed the capacity risks associated with particle accelerator experiments, including those at CERN. His words had been no longer mere warning, however full of an experience of existential anxiety. He noted the direst feasible outcome in which a mishap ought to create a state of affairs known as vacuum instability. This instability ought to, in principle, cause a section transition that might resonate via the very cloth of spacetime. The effects could be a cosmic disaster, annihilating the whole universe. Rie's issues were now not confined to speculative scenarios. He committed attention to these extreme risks, albeit a low opportunity, arguing that even a small hazard need to give us pause to think and plan. The stakes are fairly excessive, and the margin for errors is razor-skinny. The scientists at CERN have meticulously evaluated the capacity dangers related to their experiments. They have carried out numerous protection protocols and measures to mitigate any feasible risks. But clinical exploration inherently involves some diploma of uncertainty, mainly whilst venturing into new frontiers. The pursuit of expertise has always been accompanied by way of a degree of hazard. Super leaps forward have frequently included unforeseen consequences. However, it is exactly this willingness to push boundaries that has propelled humanity forward. The LHC represents the fruits of a long time of medical development and embodies mankind's insatiable curiosity about the universe. But the potential risks posed with the aid of the LHC's experiments cannot be disregarded. While the chance of catastrophic activities may be low, the consequences could be tremendous. Therefore, it's far essential for scientists, policymakers, and the general public to have interaction in open speak about the moral and safety implications of such studies. In conclusion, the Huge Hadron Collider at CERN stands as a testament to human ingenuity and the hunt for expertise. However, it also serves as a stark reminder of the ability risks that include pushing the boundaries of technological know-how. Brian Cox's latest statement and the worries raised via different outstanding scientists highlight the need for a balanced approach to clinical exploration. At the same time as the pursuit of information the universe's mysteries is a noble endeavor, it have to be accompanied by means of a vigilant cognizance of the capacity dangers worried. As we stand on the precipice of discovery, we must tread cautiously, ensuring that our quest for know-how does now not inadvertently cause our downfall.